Hello everyone. In the last class, we discussed how to insert the coils in the slot in proper sequence, record winding data and stripe the winding, prepare a stepped core, lay coils, assemble and test the motor.
Task 1. Calculate windings for the developed diagram. For easy understanding of the steps, a 24 slots, 24 coil, 4 pole, 3-phase motor is considered as an example. For the motor given as an example winding calculation or as under: number of coils per phase equal to total number of coils divided by number of phases equal to 24 by 3 equal to 8 coils by phase. 2. Number of coils by phase by pole equal to total number of coils divided by total number of phases into number of poles equal to 24 divided by 4 into 3 equal to 2 coils per phase per pole. 3. Pole pitch equal to number of slots divided by number of poles equal to 24 divided by 4 equal to 6 slots per pole. 4. Coil pitch possible: A. 5 1 to 6 short corded, B. 6 1 to 7 full pitched, C. 7 1 to 8 long corded. 5. Coil pitch selected equal to 5 1 to 6 6. Coil pitch selected in short corded. 7. Total electrical degrees equal to 180 degree into number of poles equal to 180 degree into 4 equal to 720 degree. Slot distance in degrees equal to total electrical degrees divided by number of slots equal to 720 divided by 24 equal to 30. 9. Required displacement between phase in terms of slots equal to 120 divided by slot distance in degrees equal to 120 divided by 30 equal to 4 slots. 10. Winding sequence. If first phase starts in the first slot, second phase starts in the 1 plus 1, that is in fifth slot. Third phase starts in the 5 plus 4, that is in ninth slot. 11. Arrangement of coils. The coils are to be arranged in the slot in the sequence 1 to 6, 2 to 7, 3 to 8, 4 to 9, 5 to 10, 6 to 11, 7 to 12, 8 to 13, 9 to 14, 10 to 15, 11 to 16, 12 to 17, 13 to 18, 14 to 19, 15 to 20, 16 to 21, 17 to 22, 18 to 23, 19 to 24, 20 to 1, 21 to 2, 22 to 3, 23 to 4, 24 to 5. Task 2. Prepare the stator to receive the winding. Set the core if it is mangled. Lightly tap with the nylon mallet to correct the core and clean the slot to remove any old insulation paper. Select the insulation paper of the same grade and thickness or its equivalent as in the original and cut the insulation paper to the same size. Slot insulation paper must be approximately 10 to 15 mm longer than the slot length and is to be formed according to the shapes of the inner walls of the slot. The ends of the insulation are often cuffed to avoid the insulation paper from sliding off from its position. Task 3. Prepare coils. Make a ganked former or select a ready-made former according the old coil size. Select the correct size of winding wire as per the data taken. Attach the former to the winding machine, wind the designated turns and make one set of ganked coils. Insert the ganked coils in the designated slots and check their correctness. While checking, make sure that the coils are of the correct dimension so that the two coils sides should be accommodated as top and bottom coil sides in the same slot of the double layer winding, and the overhang dimensions are comparable to the template as in the original. Make necessary sets of ganked coils if coil dimensions are correct. In the example given, 2 coils are forming the gank. Choose the former according to the number of gank coils. Task 4. Lay coils in the double layer winding. Carefully examine the developed diagram in which the slot pitch is given as 1 to 6 and there will be 2 coils in a group. The left coil side of coil 1 is in slot 1 as bottom coil and the right coil side of coil 1 is in slot 6 as top coil. In double layer winding, the coil sides should be placed in adjacent slots. Modify the procedure to suit the requirement of the given motor winding. Insert the left coil sides of the first set of ganked coils in slot 1 and 2. Leave the right coil sides of the ganked coils over the stator with the leatheroid insulation paper between the coil sides and core. Insert likewise 2 more sets to ganked coils in slot number 3, 4, 5 and 6 like step 1 and 2. Place a separator insulation over the bottom coil side of slot 6. Insert the right coil side of the first coil in slot number 6 as the top coil side. Task 5. Connect group leads, testing and varnishing. Bring out the group ends, connect, solder and insulate the groups. Connect the lead cables to the group connections and solder them. Tie the hemp threads in the overhangs to secure the sleeved joints and face separator insulations. Shape the overhangs and check with the template. Test the windings for continuity and earth faults. Assemble the motor if the test results are satisfactory and run it for 10 times. Dismantle the motor, impregnate the windings and dry them. If the results are okay, assemble and test the motor on load. Recap.
In this video, we have discussed how to calculate winding for the developed diagram, prepare the stator to receive the winding, lay coils in double layer winding and connect group leads for testing and varnishing. Thank you for watching. Have a nice day.